Good evening, children. So, the end of the class, the last class, I was explaining about if the chords are equal, then they subtend equal angles at the center. Chords which subtend equal angles at the center are equal. That is another question I inform you to work out. I hope you are done. If you are not done, we'll explain it now again. That is, under the theorem we explained equal chords subtend equal angles at the center. That is, by SSS congruency we can prove they subtend equal angles at the center. Now, conversely, chords which subtend equal angles at the center are equal in measure. Take the next theorem. Theorem 10.2. Chords which subtend if the angle subtended by the chords of a circle. That is another way of giving the statement. Let us write the same statement now. That is theorem 10.2. Theorem 10.2. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Yesterday, according to theorem 10.1, what we proved, equal chords of a circle subtend equal angles at the center by SSS congruency. Today, its converse we are going to prove by using SAS congruency. Take the figure, draw a circle and condition the two chords are subtending equal angles at the center. Draw a circle of any radius with center O. The condition, they are subtending equal angles at the center. Chords which subtend equal angles at the center are equal. Here, AB and CD are two chords. We have to prove they are equal. AB and CD are two chords such that angle AOB equals angle COD. We have to prove if they subtend equal angles at the center, they are equal. So, get the figure. Below the figure, we'll mark these two are equal, radii of the circle, these two are equal, and these two angles at the center are equal. It is also given in the question. Okay? Below the figure, write what is given. Shortage of the place, I am starting from here only. You should start given below the figure itself. What is given? Given a circle Like this, if you write, we can read it as a circle C, that is COR. That means a circle with center O, radius R. A circle COR in which AB and CD are two equal chords subtend. It's a new word. Subtend means it inclines angle AOB equals angle COD. Subtend equal angles. Subtend equal angles, that is angle AOB equals angle COD. What we have to prove? To prove chord AB equals chord CD. Chord AB equals chord CD. Construction, we have joined the radius. So you write under the construction heading, join OA, OB, OC and OD. Actually, these radii should be in the dotted form, showing that they have done under the construction part. Okay? Join OA, OB, OC and OD. Now you have to write two triangles. We have to consider those two triangles, and by SAS congruency we can show that the triangles are congruent. So that you have to do it under the heading proof. That is, in triangle AOB and triangle COD, OA equals OC given angle AOB equals angle COD. It's not given. Here it should write radii of a circle. Here to this you have to write given again, then OB equals OD. Same reason, they are the radii of the circle. Radii means plural form of radius. Radii of a circle. Therefore, by side angle side congruency, side angle side congruency, triangle AOB is congruent to triangle COD. When they are congruent, just see symbolically what I mentioned, congruent. Triangle AOB is congruent to triangle COD. When they are congruent, then we can consider AB equals CD. It is its part, corresponding parts. Bracket CP. Hence true. How you prove? When they subtend equal angles, then the chords are equal. When the chords are equal, they subtend equal angles at the center. Converse, when the measure of the chords are equal, they subtend equal angles at the center. When they subtend equal angles at the center, then the chords must be equal in measure. You can verify by drawing circles and measuring the length of the chord and the angle, central angle at the center. You can verify that also. Okay? Is it clear to everybody? You have to read this statement again and again. because once you know the statement, then doing problems to prove we can directly apply this. Okay? Next question. Theorem 10.3. Take the heading. This is clear, I think. It's all clear for you. Now we'll move on to the next theorem. Theorem 10.3. Theorem 10.3. The perpendicular from the center of a circle to a chord bisects the chord. Take the statement. The perpendicular from the center of a circle bisects the chord. Most important statement. Many times we are going to use this condition. That means if you draw a perpendicular from the center, it will bisect the chord. Conversely, line joining from the midpoint of the chord to the radius is perpendicular to the chord. Okay? And view the figure, you can get an idea what exactly it reflects. Draw a circle of any radius. With center O. Draw a circle of any radius with center O. Take a chord AB. Name it as AB. And from O, draw a perpendicular OM. We have to prove the segment from the center perpendicular to AB bisects the chord. That means you have to prove AM equals BM. To that, do the construction join OA, join OB. The statement is perpendicular line from the center bisects the chord. Okay, shall we start now? Before starting, I'll give the explanation, listen the explanation, because you won't bother to listen the explanation. When I start, you will also start right. So I will explain it first, listen it. Given a circle with center O, radius R. AB is a chord, OM perpendicular to AB. To prove AM equals BM. That means perpendicular from the center bisects the chord. Perpendicular line from the center bisects the chord. To that, what construction we did? Join OA, OB. Okay, na? Then, in triangle OMA and OMB, OA equals OB. They are the hypotenuse of the right triangle. Here, they are equal because they are radius of the circle. And OM equals OM is the common edge for both the triangle. OMA equals OMB, each 90 degree. Then by RHS congruency, two triangles are congruent. Clear? Yes, take the figure. Right? Given a circle with COR, circle with center O, radius R. To prove, AB is a chord and OM perpendicular to AB. OM perpendicular to AB. What you have to prove? Come on, tell me. What we have to prove here? The perpendicular line bisects the chord means what we have to prove in the figure? Yes, AM equals BM. Very good. To prove AM equals BM. Construction. What construction we do? Construction. Yes, AM equals BM is correct. What construction we follow? Join OA and OB. Join OA and OB. Proof. In triangle, in right triangle OMA and triangle OMB, OA equals OB, radii of a circle. OM equals OM. This is the common segment for both the triangle. OM equals OM. Bracket you write common. Angle OMA equals angle OMB. Each right angle. So each 90 degree. Therefore, by RHS, right angle hypotenuse side. This is right angle hypotenuse side. This is the common side for both the triangle. These two are radii of the circle. This is 90 degree right angle hypotenuse side. By RHS congruency. RHS congruency, triangle OMA is congruent to triangle OMB. So after proving the triangles are congruent, therefore AM equals BM. They are CP, CT, corresponding parts of congruent triangles. CP, CT, corresponding parts of congruent triangles. Hence, prove. It's clear? Very important property of the circle. Perpendicular line from the center bisects the chord. That means right from the center, when we draw a perpendicular to the chord of a circle, that line will cut the chord into two equal parts. Bisects the chord means it divides the chord into two equal parts by RHS congruency. Here, given a circle where AB is a chord, OM is perpendicular to AB. For the proof, we are joining OA and OB. Now, consider the triangle OMA, OMB. These two are, that is OA equals OB, or radii of the circle. OM equals OM. This is common for both the triangles, and these two are 90 degree. OMB and OMA are 90 degree. Therefore, by right angle hypotenuse side, that is right angle hypotenuse side, that side is common for both the triangle. We can get their congruent. Once they are congruent, then we can take the remaining parts as corresponding parts of congruent triangles. CPCT, corresponding parts of congruent triangles. Clear? Aisha, clear for you? Is it clear now? By RHS congruency, we can prove the triangles are congruent. In the previous, we proved from SSS and from SAS. This is right angle hypotenuse side, RHS. CPCT, corresponding parts of congruent triangles. CPCT. That means when two triangles are congruent, remaining parts are called CPCT. Okay? Because a triangle has 6 parts, 3 sides and 3 angles. If you prove all the 3 sides of two triangles are equal, the remaining parts are also equal. They are called CPCT, corresponding parts of congruent triangles. Clear? Go through it once again. I will move on to the converse of this theorem also. Yes, go through this. Is it clear to everybody? But I will tell you children, immediately you have to practice. Okay, tomorrow you are having your test. After the test, you have to repeat the statement and repeat the work. Otherwise, it's a huge part in geometry. Okay, you cannot say that afterwards I have forgotten. So that is the reason after this class, this one, I have to give off immediately the test. I am thinking what to do while giving the test, because one mark question is not possible here. We have to work out. Okay? And many are not submitting the assignments, only few. With that, Bhuvan is very regular. Bhuvan is a regular boy to submit the assignments. Remaining are all waiting for my words, whether to submit it or not. You are still thinking. Its converse statement is, if a line segment joining the midpoint of the chord, it must be perpendicular to the chord. This statement is, if it is a perpendicular, it is bisecting the chord. Conversely, bisect means M is the midpoint. The line joining from the center to the midpoint of the chord is perpendicular to the chord is the theorem 10.4. Take the statement. Theorem 10. Yes, of course, you have to. Theorem 10.4. So 100 times I inform, don't ask any question apart from present classes only. Okay, is there tomorrow test? What question is for test? Do we write this as an assignment? All those questions you can ask me. After the class, I can give you clear answer. Please try to concentrate to this only, explanation only. The line drawn through the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. So what statement you have proved? It's reverse, converse. If it is perpendicular, it bisect. If it is from the line from the center bisect, it must be perpendicular to the chord. So based on this, take the figure. Same figure, but we are not showing it is a perpendicular. It is line from the center is bisecting. That means M is the midpoint. We have to show OM is perpendicular. Get the figure? These proofs are not given clearly in the textbook, but I will show you the theorem. Theorem 10.5 is taken off. That construction, that one and only line passing through the three non-collinear points, that has been removed. Apart from that, remaining 10.1, 10.2, 3 and 4 are all for the theorems, and theorem based problems also we have to find it out. Okay. In the previous question, OM was perpendicular to AB. Here, OM is a line from the center joining the midpoint of AB. Here we have to prove it is perpendicular. Okay, now it's clear now what the difference of the previous statement and present statement. Okay, there it was perpendicular. We need to prove that they are bisecting it. Here M is the midpoint. We have to prove OM is perpendicular to AB. Is clear? Let us write the answer. Given a circle CO, R in which AB is a chord and M is the midpoint. M is the midpoint of AB. M is the midpoint of AB. To prove, what we have to prove? What we have to prove, please? What we have to prove? Yes, OM is perpendicular to AB. Very good. OM is perpendicular to AB. Proof. In triangle AOM, triangle BOM, OA equals OB. Why OA equals OB? What is the reason OA equals OB? Yes, radii of a circle. Good. Radii of a circle. AM equals BM. Since M is the midpoint. M is the midpoint. And which is the common segment here? Which is the common segment? We have taken OA equals OB, AM equals BM. Which is the common segment? OM. OM equals OM. Reason, it is the common part. Which congruency? Which congruency we can prove they are congruent? Which congruency we can prove? Yes, common is OM equals OM. Which congruency? Yes, SSS. Yes, SSS. Congruency. Triangle AOM is congruent to triangle BOM. So when they congruent, just see when they congruent, we consider these two are CPCT, 1 and 2. 1 and 2 are CPCT. So I will write here. Shall I write in the end? Therefore, angle 1 equals angle 2 because of the reason corresponding parts of congruent triangles. But we have to prove it is 90 degree. How can you prove angle 1 equals 90 degree? angle 2 equals 90 degree. Can anyone give the steps? How can you show that they are equal to 90 degree? I'll give a big clap to you if you do. How it is 90 plus 90, 180? You have to prove it is 90. Very good, Yashas. They form linear pair. Very good. But angle 1 plus angle 2 equals 180 degree linear pair angles. Since angle 1 equals angle 2, we can write angle 1 plus angle 1 equals 180. 2 of 1 equals 180. Angle 1 equals 90 degree. Therefore, OM is perpendicular to AB. Yes, good. Now, complete it and check it once. Is it clear, children? Very important concept here. All the 4 properties. 10.1. So today I cannot give any homework because you have to practice for tomorrow's test. Okay, we'll see. Theorem 10.1, equal chords subtend equal angles at the center. Theorem 10.2, chords which subtend equal angles at the center are equal. Theorem 10.3, perpendicular line from the center bisects the chord. Theorem 10.4, line from the center joining the midpoint is perpendicular to the chord. Theorem 10.5 is deleted from your chapter. Now one more practical work. How to find out center of a circle. Okay, this is clear to everybody because later with the basis of this property we have the problems to solve. So these statements you have to repeat like lines and angles, how the statements are you are recalling. Same type here also you have to repeat it again and again. Next question, it's not the theorem. Question, suppose you are given a circle. Suppose you are given a circle, give a construction to find its center. That is, without knowing the center, first you have to draw a circle using any circular object. Okay. Later, you have to find out its center of the circle. How to find out the center of the circle is the question. Okay? Given a circle, now we have to give the steps involved to find out the center of the circle. Since you don't have any circular object, now use your compass for the circle construction. But without using, we have to check out now whether the center of the circle is right or wrong. So now, if you have any circular object, you can use, okay, either coin or a bangle, or else use this common only. Draw a circle of any dimension without using its center. That means you can use any circular objects. Otherwise, use your own geometrical compass. Now, after this, first step here is draw a circle using any circular object is the first step. Second step, take 3 non-collinear points. And you know what we mean by collinear. Points which are all on the same straight line are collinear. Non-collinear means points which are not in the same straight line. Like this, you can take A, B and C. Now join AB and BC. AB and BC. So you know how to construct the perpendicular bisector. You already done in the construction chapter. Make use of your compass and construct the perpendicular bisector to AB as well as BC. Taking more than half, cutting arcs on both the sides, either side like this, using your compass, taking more than half of AB, draw arcs and join the intersected arc with the dotted line. Same thing, you do it for the side BC also. To the side BC also, taking more than with convenient radius like this, cut off the former arc. More than half, ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ತಗೊಳ್ಳಿ, ಎರಡೂ ಕಡೆನೂ ಸರ್ಕಲ್ ನ ಆರ್ಕ್ ನ ಡ್ರಾ ಮಾಡಿ. Then the intersected arc you have to join it. The point of intersection of two perpendicular bisector gives the center of the circle O. You can check it using that point. If you again take a circle, it will coincide, you will get the center of the circle. Now the question they are given, you have to give the steps involved to get the center of the circle. I will give the steps, take down the steps. Okay. Step 1. Draw a circle using any circular object, or you can mention using bangle. First point. Point number 2. What is the point number 2? What is the point number 2? Not remember? Yes, it's not the collinear points. What is the point number 2? Take any 3 non-collinear points. Non-collinear points. A, B and C. Take 3 non-collinear points. Next, what is the third step? Join AB and BC and construct the perpendicular bisector to AB and BC. Construct the perpendicular bisectors to AB and BC. Next, let these bisectors intersect at point O. Now, O is the center of the circle. Now, O is the center of the circle. Yes. Clear? How you are constructed, how you got the center of the circle? I have given steps of construction. Using that, you can again recall and do the construction. This is one of the active based question in this chapter. Without using center, how to construct or how to locate the center of the circle. Is it clear? Do you feel this circle chapter is easy? It's like a creative work. Okay. Next. Next question. Given an arc of a circle, complete the circle. An arc of a circle means it is a part of a circle. Okay. Given an arc of a circle, we have to complete the arc of a circle. To complete the arc of a circle, it requires its center. And we know how to get the center of the circle. This is the question. Next question is that given an arc of a circle, complete the circle. Next question. Given an arc of a circle, complete the circle. Taken the question, I will show you how to complete a circle by locating the center of the circle. You might have got an idea how to do this. Anyhow, in the beginning, I will show you the procedure. The given condition is, this is the given arc. We have to complete the circle. Okay? Minute. It is incomplete circle. Just they are given the part of a circle. It is arc. Okay. Now we have to complete the circle. To complete the circle, we have to locate its center, and just now only we have the idea how to locate the center of the circle. Same procedure here also. This is the given arc P, Q, R. Take three non-collinear points on the given arc, then join A, P, Q and join Q, R. Okay. Now, taking more than half of PQ, draw an arc on the both sides of the PQ, cut off the former arc, Now join the intersected arc with the dotted line. Whatever construction you do, try to show that in a dotted line or using any color pencil. Same thing, you do it for the part QR. Taking more than half of QR, draw arcs on both the sides with R as center, cut off the former arc like this. Okay, don't do double arc and all. It should be very light, okay, and very minute arc. Again, draw the bisector. Both are intersecting. Name this point as O. Now we have the center of the circle. Using center of the circle, now complete this arc. That is with the radius OR or OP, complete the circle. By dotted line, you complete the circle like this. It is in the beginning, it was given only the part of the circle. Now finding the center of the circle, we completed the arc. That is the question. Given an arc of a circle, complete the circle. We completed the circle by locating center of the circle. Again, to this we require the steps of construction. Steps of construction. Given an arc of a circle, take three non-collinear points P, Q and R. Given an arc of a circle, take three non-collinear points. Second point, join PQ and QR. Next point, draw the perpendicular bisector. I will use this symbol, perpendicular bisectors to PQ and QR. Let these bisectors meet, or you can mention intersect, meet at point O. Next, with O as center, OP or OR as radius. That is what we did using compass. With O as center, OP or OR as radius. We just completed the circle, right? With radius, complete the arc, not circle, complete the arc to get a circle. This is how we can complete the given arc of a circle by locating center of the circle. By locating center of the circle, we can complete the given arc of a circle. Okay? Okay, na? Next, last question. Draw different pairs of circles. Take the question. Draw different pairs of circles. How many points does each pair have in common? How many points does each pair have in common? What is the maximum number of common points? What is the maximum number of common points? So let us write different pairs of circles. Later I will extract the answer from your side. Okay? First pair. Case 1, you write it as case 1. They are given, draw different pairs of circles. with O, with O dash. Case 1. Case 2. Here I am drawing two circles like this. Can you see? O, O dash. Case 3. So you have three pairs of circles with center O and O dash. Here, what is the difference among the three? How can you differentiate? In the first pair of circle, what is not finding? In the second pair of circle, what we are getting? In the third pair of circle, how many points are intersecting? This is the question. Can you guess? They are attached. Okay? Which are attached? Case 1, case 2. O point is there in a circle in case 1. 0 point. That means there is no common point. Both are apart. There is no intersecting point. There is a gap. That means no common point. And how many common points here in this figure? Case 2. Only one common point. One common point. Whereas in case 3, we have two common points. Two common points. Okay? That means when two circles are apart, there is no common. When two circles are touch each other, there is only one common. When two circles are intersect each other, you have 2 points common. So, to intersect, what is the next question here? What is the maximum number of common points can two circles have? No. 1, 2. Can we get 3 point of intersection with two circles? Can we get 3 point of intersection with one pair of circles? Yes or no? No. So, the maximum point required, maximum point of intersection, right answer, intersection of two circles is 2. Okay? Not more than 2 point of intersection one pair of circles have. A circle may have no common point, 1 point of intersection, 2 points of intersection, but there is maximum point of intersection of the circle is at 2 points only. Do you agree with this? I am showing here, I am not telling orally, I am showing how it could be possible. In the first case, there is no common point. In the second case, they are just touching one common point. In the third case, they are intersecting, so you have two common points. So the maximum point of intersection requires only 2 points. Okay, we'll stop here, and in the next class we have few more questions to solve based on the theorem. So after your test next Thursday class, get ready with the statements of theorem 10.1 to 10.4. Okay, so do well in your MCQ test, which is on tomorrow at 4 o'clock. You will get 45 minutes duration to answer, 30 marks, 45 minutes. Okay, read the question. Sometimes you require the working also to get the answer. Since it consists geometry part and all, you have to go through the figure, knowing the property only you can give the answer. So practice. Other chapters you already done. Only part you have to concentrate here is lines and angles. Okay children, all the best, do well. Madhumita present, Sonika present, Samhita Srinivasa present, Vijay Kumar, I don't know the name, Divya Sangari present, then Grishma present, Madhumita, Tejas, Prajwal, Aishat Hanan, yes, Arya, Adya, NPS present, yes, in the beginning only she said yes, I am present. Okay children, Yashas, Shrikant, Kaushik, they are all very regular. Good, thank you. We'll see in the next class. Okay na? Tanya, yes. Hansini present. Bhuvan, yes. Prajwal, yes. Vismaya present. Vismaya. Kevin present. Kevin. Shriya present. Kevin. Kevin from DMS. Okay, thank you children. See you in the next class. Study well for the test. Okay.